So this section 8.4 is nothing new. We're still going to be distributing one term at a time, but this section does provide a little shortcut. All right, it'll save you some time. So let's actually do number one. Let me zoom in here. And it's very easy. We distribute one term at a time. So if I take the a and multiply it by a, what do I get? I get a squared. If I take the a and multiply it by negative b, what do I get? Negative a times b. So just negative ab. And then if I take the b, and you know what, let me stay color coordinated here. And if I take the positive b and multiply it by a positive a, what do I get? Positive ba. Okay, so I want to put positive, but instead of ba, I want to put in alphabetical order positive ab. And last but not least, when I go positive b times negative b, what do I get? B squared. Negative b squared. Let me put negative and then b squared. Now, what happens after distributing? It's combining like terms. So I do have a term in the middle that's negative ab and a term in the middle that's positive ab. So I could combine those together. When I combine a negative of something plus a positive of that same something, what happens? Crosses out, eliminates, it's gone. So our answer is a to the second power minus b to the second power. You with me? And let me do this. Let me write that same answer right here on the side. Okay, so this will come in handy. This is actually part of our notes. This will come in handy when we do our homework today. Let's move on to number 2 down here. Number 2, it says the binomial a plus b squared. So in order for us to understand this, we need to expand it. We need to write the a plus b in parentheses times itself. So we write it times itself, that same base, a plus b times a plus b, and then we do what we always do, we distribute. So let's distribute. We're going to go a times a. What's a times a? A squared. A squared. And then what's a times b? That's a positive ab. And then what is positive b times positive a? Positive ba, but we're going to switch to ab. That's right. And then positive b times positive b? Positive b squared. And again, we could combine the middle terms. So I have one positive AB plus another positive AB. That will be 2 of those ABs, and it's positive. And the A squared comes down, and the positive B squared comes down. And ladies and gentlemen, that is our answer for number 2. Could we move on? How about you guys try number 3 and tell me what you get? So the answer to this one, if you expand it and do the work, it's the same thing, but there's a minus instead of a plus only on the 2ab. Let me show you. So if I go a times a, we get a squared. A times negative b, that's going to be a negative ab. And then negative b times a is another negative ba, but I'm going to write it as ab. And then negative b times negative b, that is a positive b squared. And again, the middle terms, we're going to combine them. If you owe one and you owe another, you're going to owe 2 of those ab values. Then, of course, you bring down the a squared and you bring down the plus b squared. And that's your answer for this one. So what we just did here, guys, on 1, 2, and 3 are actually the notes for today, 8.4, because it really provides a shortcut. Let me explain. If we look at number 1 again, what could we say about this first binomial being multiplied by the second binomial? What could he say about them? One's plus, one's minus, right? So whenever you have this situation, it doesn't matter what binomial you have in there. Whenever you have a binomial times the same binomial, but one's plus, one's minus, you could simply take your first term here and multiply it with itself. In other words, square it, put a minus sign, and then take your second term and square it, and that'll be the second part of your answer. I know that that sounds weird, but let's compare it right here. Check it out. Let's compare it with number 4. Okay? So we see on the class opener a plus b times a minus b. Right here you have an a, you have a b, you have an a, you have a b. One's plus, one's minus. Same binomial, but one's plus, one's minus. You guys agree? Okay, now the answer is going to be this. Now what do I mean by that? It's simply a squared minus b squared. So a is 3x. So what is a squared? That would be 3x times itself. So what is 3x times itself? 9x squared, right? 3x times itself is 9x squared, okay? Now, technically that comes from this, 3x times 3x, right? So if you say 3x squared, you're saying 3x times 3x, that's really 9x squared, okay? And that's actually the first part of your answer, a squared. Then we have a minus sign, so let me put a minus sign. And then we have b squared. So that would be 5 squared. So what's 5 squared? 25. And that's our answer. And that's our answer. So where did that 5 squared come from? It came from 5 times 5. Now, the reason why it's this simple, or the reason why the shortcut happens, or you're able to apply the shortcut, is because whenever you have a binomial with it times itself, but one's plus, one's minus, what happens to the middle terms? They cancel out. So you don't have to worry about doing the full distributive property process. It's really just like saying multiply the first ones, 3x times 3x, that's 9x squared. Multiply the last ones, 5 times 5, you get 25 with the minus sign. That always works when you have the same exact binomial twice. Okay, so let's check this out. Let's see. How about this guy? Copy that one down. That one is the same exact binomial twice, so we could apply this shortcut. So, okay, I heard you said 4. That's good. So far our answer is going to be 4x to the 6th. Because when you say 2x to the 3rd times 2x to the 3rd, you get that 4x to the 6th. Right? And now, what's the second part of our answer going to be? It's going to be minus 81. 81, because 9 times 9, 9 squared is 81. That, I mean, what I'm saying is applying our shortcut, we get that answer. Okay. Now, let's do this. Let's actually work it out. Let's show our work here. What's 2x to the 3rd times 2x to the 3rd? 4x to the 6th. What's 2x to the 3rd times negative 9? That's negative 18x to the 3rd, right? And then positive 9 times positive 2x to the 3rd. What do I get? Positive 18x to the 3rd. And then positive 9 times negative 9, negative 81. Now, again, whenever you have a binomial times a binomial, but one's plus, one's minus, what happens to these middle terms right here? They cancel out. They disappear. So our final answer is 4x to the 6th minus 81. So getting used to this shortcut of recognizing, oh, I have a binomial and a binomial, one's plus, one's minus, you know that the middle terms are going to cancel out. So all you got to do is say, okay, the first one times the first one is that answer, and the last one times the last one is that answer. Okay? And that comes from this truth. And I do have this written up on the board. So there's the truth. When you have a binomial times itself, but one's plus, one's minus, you're going to end up, you could just take this first term, whatever it is, square it, put a minus sign, take the second term, whatever it is, and square it, and you'll get your final answer. Okay? So we have these other ones too that we also did on our class opener, the a squared, or the a plus b squared. We end up with this answer. This isn't really a shortcut, but you will be able to apply it if you wanted to. Let me show you. So back to our class opener. Right here we had a plus b squared, and we ended up with a squared plus 2ab plus b squared. That was our answer. So we could technically apply this as a shortcut also, but it's not really a shortcut. I like the first one. I don't like the other two. Let me show you. Here's an example number 6, everybody copy this one down. It's 2x minus 3 to the second power. So I'm supposed to write it twice. 2x minus 3 times 2x minus 3, and distribute and combine like terms and get a final answer. But if I notice, down here on number 3, it says a minus b to the second power. So if I use this answer as a shortcut, I could take my a value and square it. What's my a value? 2x. If I were to multiply 2x with itself, what do I get? I get 4x to the second. Okay, I want to write it down here so I could leave space. And then I could look at the next term. The next term says on the answer minus 2 times a times b. Okay, so what is minus 2? Let me actually write it out so we don't get confused. Minus 2 times a, where a is 2x, so that's times 2x, times b, where b is 3, times 3. So that middle term is going to be negative 12x. And that first term is 4x squared, and that last term is b squared. So that would just be 3 squared, which is what? Plus 9, right? Now, like I said, I don't really like this. I don't even consider this a shortcut. I would actually rather just distribute and combine like terms. So you see how I already got the answer, but I would rather just write it twice and actually distribute. So, okay, 2x times 2x, 4x squared. 2x times negative 3, negative 6x. Negative 3 times 2x, negative 6x. Negative 3 times negative 3, positive 9. So we combine those middle terms, getting a negative 12x, and you have the 4x squared in the front and the plus 9 at the end. Notice that it's the same answer, and I would actually rather write it twice and show my work and combine like terms. The bottom line is this, guys. We need to understand that if we have a binomial times a binomial, one's plus, one's minus, what happens to the middle terms? They cancel out. So you don't have to go through the whole process. When you have a binomial times itself, the middle terms do not cancel. It's kind of like doubling the middle term, right? Negative 6, double it, it becomes negative 12. So that's about it. That's all there is to it. I wouldn't even worry about 2 and 3. I would just write it twice, work it out, distribute, combine like terms. But the first one's a nice shortcut. So let's jump to our homework. So on our homework, 8.4 WSP, by the way, we're going to do the even ones. You could do all of them if you want, but like even number 29 is a typo. I would scratch out 29. But we're going to do the even ones. So if I take a look at number 2, I wouldn't worry about using a shortcut right there. I would just write it twice. So I wrote it twice. Then I would actually distribute q times q, q to the second. Q times 8, positive 8 of those q's. And then 8 times q, that's another positive 8 of those q's. And then 8 times 8, positive 64. So as you could see, just like on the class opener, those middle terms, they double, right? The 8 doubled becomes 16. But I wouldn't even worry about a shortcut. Just show your work the way I did right here. Your final answer will be q2 plus q squared plus 16q plus 64. Done. So I wouldn't worry about applying a shortcut when you have a binomial squared. I would work it out. Write it twice, distribute, combine like terms, get your answer. But where you do have a binomial times itself and one's plus and one's minus, right there it's nice to use a shortcut. Now you don't have to, but it's nice. Look, let me just jump straight to the answer down here. Now remember, when you do have a plus b times a minus b, you could do the shortcut a squared minus b squared. That's your answer. So right here we really do have a plus b times a minus b. So I could do a squared, so that would be z times itself. What's z times itself? Z squared. And then minus b squared. What is the b value? It's 13. What is 13 times 13? 169. So your answer is this, z squared minus 169. Do you have to use a shortcut? No. I mean, you could just do it the way we always do it. You're going to get to that answer anyway. But after doing it so many times, you're going to realize, hey, if I do have a plus sign and a minus sign, that's the only difference. The middle terms will cancel out. So check it out. Let me show you that they cancel out. Z times z, z squared. Z times negative 13 is negative 13z. And then positive 13 times z, that's a positive 13z. Then positive 13 times negative 13, that's negative 169. And again, like I mentioned, the middle terms cancel out. So your answer is what we had on the shortcut, z squared minus 169. So in regards to today's notes, we did not learn anything new, minus this, or except for this pretty cool shortcut. When you do have a binomial times itself, but one's plus and one's minus, it's easy to get your answer. What's the answer here going to be using the shortcut a squared minus b squared? In other words, 7k times 7k, what's that? 49k squared. And then minus 3 times 3 is 9. Boom. That's your answer. No work needed. But if you want to, go for it. 7k times 7k, 49k squared. 7k times negative 3, negative 21k. Positive 3 times positive 7k, positive 21k. And then positive 3 times negative 3, negative 9. So once again, we already know these guys can't cancel out, and there's your answer that we had on the shortcut anyway. So the shortcut's great when you have 1 plus, 1 minus. Make sense? Should we try another? No? No? Even like 32, you guys want to apply a shortcut on 32? No? You guys want to see that? No? Yes. Let me just show you. Come on. This is the last one. Okay, so what would, if you applied the shortcut, a squared minus b squared is going to be your answer on this case only. Now you can't do this with all of them. Only when you have the same identical binomial, one's minus, one's plus, you could use this shortcut. You don't have to, you could work it out the way we always do. But anyways, with the shortcut, what's your answer going to be? My answer right there. 4b to the fourth minus g squared. Right? A squared minus b squared. The a, when you square it, it becomes 4b to the fourth minus b squared. The b is really g in this case, so it becomes g squared. Again, you don't have to use a shortcut. 2b squared times 2b squared, 4b to the fourth. 2b squared times g, that becomes positive 2b squared g. Negative g times 2b squared, that becomes negative 2gb squared, but I'm going to write it in alphabetical order, b squared g. Then negative g times positive g, that's negative g squared. Once again, we already know that the middle terms are going to cancel out. That's why we're able to use this shortcut. The 4b squared comes down, the minus g squared comes down. We're done. So you don't have to show your work on those guys. You can just apply the shortcut. But over here, where you actually have to write it twice, I do expect to see some work. So you write it twice, and then you distribute. 6 times 6 is 36. B to the third times b to the third is b to the sixth. You add those exponents. And then 6b to the third times negative g, that's negative 6b to the third g. And then negative g times positive 6b to the third, that becomes a negative, again, 6, but instead of gb to the third, b to the third g. So it'll look the same as the previous one. And then negative g times negative g, positive g squared. These guys don't cancel out, but they actually, it's like doubling it. It becomes negative 12 b to the third g. And in the front you have 36 b to the sixth, and at the back you have plus g squared.
It doesn't turn into positive because it's negative to negative.
Yeah, this is not multiplication. If it were, you'd end up with positive 36, right? But we're not multiplying. Up here we were multiplying, but down here we're just adding and subtracting depending on the sign. So you owe 6, you owe 6, you're going to owe 12.